Hi dear students, welcome back to online classes. In today's class we are learning about the energy level diagram of a Lyman, Balmer, Parsons, bracket and a fund series. What is the definition of an energy level diagram? A diagram in which horizontal line represents discrete energy levels and vertical line represents the transition of electron from higher orbit to the lower orbit is called as energy level diagram. When that energy given to the ground level of an electron, that electron jumps from ground state to excited state and return back to the metastable state. It emits radiation. Due to that radiation, energy level will be formed, or spectral level lines will be formed. There are totally 5 spectral lines or spectral series is there. One is the Lyman, Balmer, Parsons, bracket and fund series. In that diagram, horizontal line shows that the number of discrete energy levels and vertical line shows that the transition of electron from higher orbit to the lower orbit. Okay. First one important concept, this one is what is the energy level diagram? Okay. Definition, what is energy level diagram? This one is a question. What is energy level diagram? Okay, this one is one more question. Definition, a diagram, the diagram in which horizontal lines represents the discrete energy levels and vertical lines represents the transition of an electron from higher orbit to the lower orbit. Lower orbit is known as energy level diagram. Energy level diagram. Here horizontal line represents the discrete energy levels, number of energy levels. Okay, N1, N2, N3, N4, N5 like that. N1 means Lyman series, N2 Balmer series, okay, N2 Parsons series, N4 bracket series and N5 it is a fund series. Okay, and vertical line represents the transition of electron jumps from an higher orbit to the lower orbit is known as energy level diagram. Okay, now sketch the energy level diagram. How to sketch the energy level diagrams? Sketch the energy level diagram diagram for hydrogen atom. For hydrogen atom, draw the energy level diagram of an hydrogen atom. Okay, here for that transition of electron from higher level to lower level, okay, its energy equation is given by En is equal to minus 13.6 divided by n square electron volt. The energy of an electron, the energy of an electron of hydrogen atom in different energy levels, or orbits, different energy levels or orbits is given by En is equal to minus 13.6 divided by n square eV, electron volt. En is equal to minus 13.6 divided by n square eV, where n is equal to 1, 2, 3 up to dash infinity. Now, transition of electron from higher orbit to the lower orbit. Okay, here first line I am considering the ground state. This one is called as ground state. N is equal to 1. This one is called as ground state. Next, excited states. This one is N is equal to 2. Next, this one is N is equal to 3. N is equal to 4. N is equal to 5. Here N is equal to 6 dash dash. And here transition of electron from higher orbit to the lower orbit. Okay, this side we consider as an energy in electron volt. Transition of electron from higher orbit to the lower orbit. Here electron jumps from second orbit to first orbit, like this. Second orbit to the first orbit, third orbit to the first orbit, fourth orbit to the first orbit, fifth orbit to the first orbit. Okay, this one you call as, which series? This one you call as Lyman. Electron transition occurs from higher orbit to the first orbit. This series is called as Lyman series. This one you call as Lyman. Next one, electron transition occurs from higher orbit to the second orbit. This one is the second. Okay, third to second, fourth to second, fifth to second, sixth to second. Okay, electron transition occurs from higher orbit to the second orbit. This one we call as Balmer series. Okay, next one, electron transition occurs from higher orbit to the third orbit. This one is third. Okay, fourth to third, fifth to third, sixth to third. Okay, this one is called as Lyman, Balmer. This one is called as Paschen. Electron transition occurs from higher orbit to the third orbit. That is called as Paschen series. Now, fourth one, electron transition occurs from higher orbit to the fourth orbit, like this. Higher orbit to the fourth orbit. Okay, this one you call as bracket series. This one you call as bracket series. And last one, electron transition occurs from higher orbit to the fifth orbit. Higher orbit to the fifth orbit. This one you call as Fund series. This one you call as Fund series. Fund series. Okay. Here horizontal line represents the number of orbit and vertical lines represents the energy levels. Energy levels. Here ground state orbit its energy. Ground state orbit its energy minus 13.60 electron volt. Here how to write this one values means here by using the formula En. En means here orbit, one orbit. E1 is equal to energy of the first orbit. Ground state orbit is equal to minus 13.6 divided by, in the place of N, first orbit, that is a N. N is equal to 1. 1 square. Okay. Minus 13.6 divided by 1 square means 13.6 electron volt. Same. Second orbit. In the place of N, 2 square. 2 square means here 4. Minus 13.6 divided by 2 square. Its value minus 3.40. Minus 3.40. Okay, like that. In the place of N is equal to 3 square, its answer minus 1.51. Okay, next, fourth one. In the place of N, 4 square. 4 square means here 16. Minus 0.85. And fifth one, minus 0.54. In the place of N square, 5 square. 5 square means 25. 25 square. 25 square, it means minus 13.6, sorry, 5 square 25, minus 13.6 divided by, in the place of N, 5 square 25, minus 13.6 divided by 25, its answer minus 0.54. Okay, and last one, infinity. Okay, this one you call as ionization state, a quantum. This one you call as quantum. Okay, higher states we call as quantum. Okay, and when it goes to increasing order higher state, at that time its energy value E infinity is equal to 0. E infinity is equal to 0. Okay, this one we call as energy level diagram of 5 spectral series. That is Lyman, Balmer, Paschen, bracket and Fund series. Okay, students, next one is the ionization energy. Ionization energy means it is the minimum energy required to remove electron from the ground state of the atom to the infinite distance with respect to the nucleus. When you give some amount of energy to the ground state electron atom, that electron jumps from ground state to infinity state. Okay, that one you call as ionization energy. Definition: the minimum energy required, the minimum energy required to remove an electron from the ground state of the atom to the infinite distance with respect to the nucleus. With respect to the nucleus. Is called as ionization energy. Is called ionization energy. Okay. Equation: the minimum energy required to remove electron from its ground state to the infinite distance with respect to the nucleus is called as ionization energy. Okay. Note point. Note: the process of removing electron process of removing electron from the atom is called ionization energy. The process of removing electron from the atom is called as ionization. Here, how much energy is required to ionize the electron means formula E is equal to E2 minus E1, higher energy state minus lower energy state. Here higher energy state means you consider as an infinity, because here energy required to transition of electron from ground state to infinity state. So in the place of E2 infinity minus in the place of E1, that is the ground state. What is the value of ground state energy? That is a minus 13.6 electron volt. Minus into minus plus, that is the 13.6 electron volt amount of energy is required to ionize the electron from ground state to infinity state. Next one, excitation energy. Excitation energy. The amount of energy required, to raise the electron from a lower energy level to a higher energy level, is called excitation energy. The amount of energy required to raise electron from lower energy level to a higher energy level is called as excitation energy. Okay, next note point. The process of sending the electron from its orbit to higher orbit, that process is called as excitation. The process of sending an electron from its orbits to a higher orbit, is called excitation. Here energy required to sending an electron from its orbit to higher orbit, that process is called as excitation. That process is called as excitation. How much of excitation energy is required to electron jump from its orbit to higher orbit? For hydrogen atom, the first excitation energy is E is equal to E2 minus E1. E is equal to E2 value minus 3.4. Minus of minus E1 value, ground state energy value minus 13.6. Okay, its total answer, this one is a minus into minus plus, minus 3.4 plus 13.6. Its answer, total energy answer, excitation energy answer 10.2 electron volt. Okay, 10.2 electron volt. This one you call as excitation energy to require electron jumps from its orbit to higher orbit. Okay, up to here energy level diagram and the definition of ionization and excitation over. Thank you.